Okay, for this one we're going to solve the second order non-homogeneous differential equation. Now notice the right hand side does not have the form of a constant, a polynomial, a exponential, a sine or a cosine function, or some product thereof, or the sum of the things that look like this. Cosecant of t does not fall under one of those categories, and so the method of undetermined coefficients cannot be used for this particular example because the right-hand side doesn't have the right form. So we have to plow ahead with the variation of parameters. To get started, let's figure out the two independent solutions for the homogeneous equation. R squared plus 4 equals 0 is the characteristic equation, and this has two roots, r plus or minus 2i. And so therefore we have the two fundamental solutions are going to be cosine of 2t and sine of 2t. From this we can get the Wronskian. So cosine 2t, sine 2t. Derivatives, we get negative 2 sine 2t and 2 cosine 2t. So we figure out the determinant, multiply this way, we get 2 cosine squared 2t, minus, multiply this way, negative 2 sine squared 2t. Factor the 2 out, cosine squared 2t plus sine squared 2t, which wonderfully is only equal to 2. So that's our Wronskian. Okay, now we have a couple of integrals to figure out. First integral, u1 of t equals negative integral y2 of t times g of t divided by the Wronskian of t dt. y2 was equal to sine 2t. G of t was the right-hand side, cosecant of t, divided by 2 dt. So to do this integral, I first start with a trig identity, 2 sine t cosine t times cosecant of t dt divided by 2. Now sine of t times cosecant of t is 1. Those are inverse functions, or inverses of each other. Divide 2's cancel, so I get integral of cosine of t dt, so I get simply sine of t plus my first constant c1. Okay, now let's switch over to the second integral that we have to do. So let me do this over here on the right. u2 of t is going to be equal to integral of y1 of t times g of t divided by the Wronskian of t dt. y1 was cosine 2t, so integral of cosine of 2t times cosecant of t, all divided by 2 dt. Okay, for this one, let's use a double angle formula for cosine. So I get integral. Okay, so I have a 1/2 here from down the bottom. I have 1 minus 2 sine squared t. That's equal to cosine of 2t times cosecant of t dt. Now multiplying out, we get 1/2 cosecant of t. Then if I multiply out, 2 divided by half cancels. Sine squared of t times cosecant of t is minus sine of t dt. And for this, we just simply use the formula for the integral of cosecant. Negative 1/2 natural log of cosecant of t plus cotangent of t. Then I have integral of negative sine, which is plus cosine of t, plus the second constant c2. So there's the u1 and u2, the two integrals that I need to be able to do this calculation. Putting these together, we get the form of the general solution. Y of t is equal to u1 and I forgot the minus sign here. I apologize. This minus sign got lost. So this minus sign got lost. I apologize for that. Negative sine t plus c1 times cosine of 2t plus this thing, negative 1/2 natural log cosecant of t plus cotangent of t plus cosine of t plus c2 times sine of 2t. Okay, from this point forward, we can try to make this as simple as possible. So first let's get the constants in front. c1 cosine 2t, then over here plus c2 sine 2t. Over here I have minus sine of t cosine of 2t. Here, I'm going to take this part first. I have plus sine of 2t cosine of t. Then the last part is minus 1/2 sine of 2t times the natural log of cosecant of t plus cotangent of t. Okay, we can make this a little bit easier. So here I have sine of the first, cosine of the second, minus cosine of the first, sine of the second. So that's actually the trig identity for sine of the first minus the second. So sine of the first minus the second is sine of the first, cosine of the second, minus cosine of the first, sine of the second. Minus 1/2 sine of 2t, natural log cosecant of t plus cotangent of t. And then the obvious simplification on the last step, c1 cosine 2t plus c2 sine of 2t plus sine of t minus 1/2 sine of 2t, natural log of cosecant of t plus cotangent of t in absolute value. So that's the answer. This one cannot be done by the method of undetermined coefficients because of the form of the right-hand side, and so there's no shortcut other than just simply doing those two integrals and using trig identities as necessary in order to get them.